This lecture is on the one population standard or one population mean hypothesis test using the p-value approach. If you've already watched the critical value approach, it's exactly the same thing except step 4, 5. And then if you reject, you have to add another sentence to your interpretation. Alright, so our scenario is that the pH balance of arterial plasma in adults with arthritis has an average of 7.4, so that's mu, with a population standard deviation of 1.9, so that's sigma. A random sample of 31 patients with arthritis were given a new drug, and it was found that their pH balance ended up having a mean of 8.1. We want to test at the 5% significance level whether the medicine has changed the pH balance of the arterial plasma. Alright, again, this is a z-test because we know sigma. First step is always to state our null and our alternative. The null is what they say it is, or what it used to be, which is 7.4. The alternative is what we're testing. I just said, has the plasma pH changed? So that means, is it different? So we put not equal to. Step 2 is our significance level. Just restate that alpha is 0.05. Step 3 is our z-score. Since we're doing a z-test, it's a z-score. So z equals x bar minus mu divided by sigma, remember, divided by the square root of n, which was 31. Remember, you divide first, subtract, and then you divide it again, and you get 2.05. Now, we're going to use the p-value approach this time. And I said it's all going to be the same until we get to that last part. Now, this is a two-tailed test because it's not equal to. That means what we want to do with the p-value is to find the probability of being in the tails of our test statistic. Well, we know that one of our test statistics is 2.05 because that's what we just calculated. With the two-tailed test, though, we want to know if it's greater than 2.05 or less than negative 2.05. If we had gotten a negative 2.05, we would have looked at the positive. Always the positive and negative. So we look at our z-table. We go down to 2, cross to 0.05 on the negative side, and what you get is that this is 0.0202. Because of symmetry, this probability will also be 0.0202. So together, our p-value is 0.0404. Now we're ready for our decision, reject or fail to reject. With the p-value approach, we always see if p is less than or equal to alpha. So is 0.0404 less than or equal to alpha? Remember, which is 0.05. And it is, so we reject. If our p-value had been greater than, we would have failed to reject. Since we're rejecting, we have 3 sentences in our interpretation. The first one, just like before, says it's different from 7.4. The second one, sentence, tells us if it's greater than or less than 7.4 based on our z-test. The third one tells us the strength of the evidence against it being 7.4. So, at the 5% significance level, the data do provide sufficient evidence to conclude that the mean pH of all arthritis patients differs from 7.4. Now, that's our first sentence, just that it's different. Now we put if it's less than or greater than. We are, remember that it has to add up to 100%, so 5 plus 95% would be 100. So we are 95% confident that the mean pH of all arthritis patients is greater than 7.4. It's greater than because our z-score is positive, meaning that it's larger than what's expected for our mean. The last sentence, and it's only for using the p-value, we have to put the evidence against the mean, or the null. The evidence against the mean being 7.4 is, now we look at our p-value, 0.0404. Since it's between 0.01 and 0.05, based on our table, that is a strong evidence. That concludes the one population mean hypothesis test using the p-value approach.